Good morning, good afternoon, or good evening. I don't know what time of the day you are watching this, so thank you for joining me. So this could be your second or third lesson in multiplying or dividing equations. Second for if you chose to bypass the other video, and third if you decided to do all of the work. So this one is kind of doing things a little differently. It still has the same ideas, but you're kind of taking this step a little further. So what you have to do is backtrack and remember reciprocals. So reciprocals typically involve fractions. So if I give you 3 over 4, what is the reciprocal of 3 over 4? And the definition, by definition, reciprocal is two numbers whose product is 1. So that is two numbers. When you multiply them together, it equals 1. So a reciprocal, to find the reciprocal, you are flipping the fraction. So this is 3 over 4. It's going to be 4 over 3. And we know that this is a reciprocal, is when you multiply the reciprocal to its original number, you're going to end up getting 12, 3 times 4, over 12, 4 times 3, and that equals 1. So this fits the actual definition of a reciprocal. So now let's do some problems on one-step equations involving reciprocals. And honestly, if I'm giving you the truth, I actually prefer these problems done in 2 steps. In Algebra 1, when I teach it in 2-step equations. I think it's a deeper understanding. Because we're doing one-step equations, we're kind of skipping some of the inverse operation rules a little bit. It's a gray area thing right now. But we're using reciprocals because when you look at the side of the variable, you have a fraction next to it. And the whole purpose of solving an equation is to get the value of the variable. So in this case, you have a fraction next to your variable. In order to isolate the variable, you need to multiply it by its reciprocal. And because a fraction is 3/5, you flip it, you get 5/3. Whatever you do to one side, you have to do to the other side. And now you're going to have 3 times 5 is 15. 5 times 3 is 15. And that's going to give you 1. So you can just easily just cross off the 3's and then cross off the 5's. You're going to be left with just x on the right side. On the left side, you have a fraction times a whole number. And remember, just put a 1 underneath your whole number. And this way, you're multiplying a numerators together and the denominators together, which will give you 30 over 3. So x equals 10. And you can check to see if what you did was correct, because on the right side, your whole purpose is to make this true. So 3/5 times 10, and I'm going to put that 10 as x, over 1 equals 6. 30 over 5 equals 6, and 6 does equal 6, so it's true. Let's do another problem involving reciprocals. And remember, always go to the side where the variable is first. That's your indicator on what you're doing. You have two fractions here, and it's very easy to take the reciprocal of the wrong number. But your whole purpose here is to get the m by itself on the left side. So you're multiplying 1/15 times n. The reciprocal of 1/15, 1 over 15 is 15 over 1, and you're going to multiply the same thing onto the other side. And like I said in the other problem, you can just cross off the 15s and then cross off the 1s. That'll just give you 1. So you're going to have m equals 2 times 15, 30, over 3 times 1, 3, and that gives you 10. And you could always simplify before you multiply. So 3 and 15, you can simplify that. 3 goes into both of them, so this would be 1, and this would be 3. So, not 3, sorry, 5. So 2 times 5 is 10. 1 times 1 is 10. So you get the same answer. And let's check to see if this is true. So 1/15 is equal to 2/3. So 1/15 times 10 over 1. I don't know why I'm writing 1 over 5. This is 15. You're probably looking at me like I'm crazy right now. 2 over 3. So this is going to give you 10 over 15 is equal to 2 over 3. And 10 over 15 is 2/3. So this is right. So your answers for these two problems, m equals 10 and x equals 10. Let's go on to some word problem action here. So Jenna raised 2/3 the money at the bake sale as her friend Amy. Jenna sold $50 worth of pies at the bake sale. Write an equation and determine the amount that Amy raised at the bake sale. So what we do know is that Jenna raised 50. What we don't know is how much Amy raised. So they're saying that Jenna raised 2/3 the amount as Amy raised. So this is going to be 2/3 of Amy is equal to Jenna. That's how much she raised. And because we know that Jenna raised 50, we can substitute 50 or replace that J with the 50. And this is the equation that you want to start off with. And now actually solving it. So the variable is on the left side and you have a fraction. So the reciprocal over 2 over 3 is 3 over 2. So we're going to multiply both sides by 3 over 2. These cancel off and you're going to be left with A is equal to 150 divided by 2. Or you could have easily done 25 over 1, okay? And then you simplify that, you're going to get A is $75. So Amy raised 75 bucks. Whoops, bad circling, but you get the point. How about you try this one by yourself? Pause the video. All right, welcome back. Let's see if you get the same as I do. So Yvonne is 2/5 times younger than her grandmother Crystal. Yvonne is 30 years old. Write an equation and solve the equation to determine Crystal's age. So we know that Yvonne is 30. We don't know how much Crystal is. So it's saying that Yvonne is, remember, the word is translates to equals in mathematics. When you're dealing with a word problem situation, it's a lot of the times this happens. So Yvonne is 2/5 times younger than her grandmother Crystal. So that's you have two variables right now, and it's not what we want. What do we know the value of either one of these variables? Yes, we do. We know that Yvonne is 30, so it's going to be 30 is equal to 2/5 k. Variables on the right side, we want to isolate that k. We have a fraction, so we're going to multiply it by its reciprocal, which is 5 over 2. The 2's go away. 5 over 2. So this is going to give you 150 divided by 2 is k, and k is 75. Somehow, both these word problems have the same answer. Crystal is 75 years old. I hope this helps with a more challenging set of problems for section 6.3. Thanks for joining me.